mapping data flows in Azure Data Factory. So I've been working with Azure Data Factory for a while, but recently I also had the opportunity for a data migration engagement, use mapping data flows. So I thought I'll use this Geek Night to actually share more details about what I learned. And so the talk is essentially will go in a way where we'll first talk a little bit about ETL, then we will touch upon what Azure Data Factory, the major components of it. Then we'll dive into mapping data flows. And at the end, I'll show a live demo, like a quick demo on how we can actually use that data flow to actually do some transformations, get data from a particular source to a required destination. So in terms of data engineering, we essentially have data pipelines, which is kind of the crucial component of it, where we utilize it to kind of move data from different sources and then do some kind of transformations on top of it, and then take it to a required destination. So this is what we actually do in ETL, which is like a very famous pattern in the data pipeline. And we can have multiple number of sources where we need to kind of use some connector to extract the data, do the required transformations, either to standardize the data to a required format, or we want to do some calculations on top of it. So we ensure that the data is in like a prescribed format. And at the end, like we take it to a data warehouse where we can have people do some kind of analytics on top of it, or we can help business make some kind of decisions. And some machine learning models we can actually build also on top of them. So all this kind of comes under the ETL flow. So in Microsoft Azure ecosystem, Azure Data Factory is one such tool which helps you do data integration as well as ETL. Yeah. So Azure Data Factory essentially is like a visual builder wherein you can actually drag and drop the required activities. Let's say I want to actually copy data from a particular source to another. Microsoft Azure has in Data Factory has an activity for copying. And if let's say you want to call Azure Databricks notebook run something, that also is an activity which you just need to add in the canvas. And as such, it helps you kind of structure in a sequence of steps what you actually want to do to the particular data from a different source, and how you want to look in a particular destination. So essentially, it's a code-free ETL as a service. It kind of tries to put forth the notion that you don't need to be very knowledgeable in coding to actually be able to build ETL services. We have seen solutions like Airflow where you actually need to know Python to be able to build DAGs. But in Azure Data Factory, we will be able to utilize the UI component of Azure Data Factory to build the or to orchestrate the activities that we need to run. So we kind of break it down into 5. The first one is ingest. So Azure Data Factory itself gives you like a lot of connectors. Let's say you have some data in Azure SQL, you have it in a storage account. It has inbuilt connectors where you just need to tell how it needs to connect, like connect via username, password, or connect via like a managed identity, and it will be able to fetch the data for us. Once that is done, we move to the next step, which is control flow, wherein we say like it's more like your if conditions, for loops. Maybe we have like 10 different tables we need to read data from. Then we in a for loop we kind of set that as a step. And the third one, which is the important one, which we are actually going to be focusing about today, is data flow, wherein it's not just having data, but we will be able to do some transformations on top of it. Underneath data flow, it actually uses Spark clusters to actually run the transformations. So everything that we build in the UI gets converted into Spark code internally, and then it runs on top of the Spark cluster. But here, there is also the caveat that you won't have that much control. Let's say similar to Databricks. In Databricks, you might be able to use notebooks, but in this structure of using doing transformations, there might not be too much control. But with that, it gives you the flexibility to be able to quickly get started with doing all the transformations. And the last two is schedule, wherein like we can keep like a weekly schedule, daily schedule, or if in one of our project we had like if a particular file gets dropped into a storage account, an event will be triggered, and that will actually trigger a pipeline. And the last one is like a monitoring section where you can set some alerts if some particular pipeline fails, or you can actually filter on when the pipeline, which all pipelines succeeded in a particular time period. All these we'll be able to do. So this is like the home page of Azure Data Factory. In the demo, I'll maybe cover a little more on different sections of Azure Data Factory. Maybe I'll, yeah. Yeah, so this is Azure Data Factory. Azure Data Factory, it has these different panes. The first was the author section. In the author section is where like you kind of tell what pipelines you actually want to set up or what data flow you want to create. It also has a section called data set, which is like I want to get a data from this particular source, or I want to get a data from this particular destination. All this can be configured in this section. And the another one is monitoring section, where all the pipelines that we have run in the past, we can actually see it. Here we can filter based on like last 24 hours, last 7 days. We can filter by pipeline name, whether the pipeline failed or it was succeeded. And if we go inside each pipeline, we'll be able to see what all individual activities in that particular pipeline was actually run and whether it failed. And we also get like the details of why it failed, all this information. And then we have manage section. In the manage section, it's like Azure Data Factory itself lets you give a sequence of steps to run. So if you want to connect to different external sources, let's say Azure, let's say you want to connect to S3, or let's say you want to connect to storage account itself, then you will need to create something called as a linked service, which is essentially telling it like use this connection strings to kind of connect to this particular external service to bring in the data for Azure Data Factory to process. So we have two created here for the demo, which I'll maybe talk more later. Yeah. So what we saw now in the UI of Microsoft Azure Data Factory, we can actually see it here represented in a way. So essentially, everything comes down to the pipeline. So pipeline is like the crucial component of Azure Data Factory. Like if you want to run something, then you need to create a pipeline. Everything you want to do, you need to define in that pipeline. And how we would define it is using activity. So maybe the first activity could be extract, like read from a SQL table. Maybe the second one could be like I've read from the SQL table, but join from another data source so that I would actually have a unified view of the data so that we can create as another activity. At the end, I've done this joining, but I want to have it in like a Parquet file, or I would like to see it as a CSV file, and you want to write it somewhere, then you create one more activity. So you have a pipeline as the overall one, and individually, internally, you can create multiple activities. And each activity, it will need to have a data set if it is actually going to get some data. So Azure SQL I was talking about, then a table will be a data set. And for Azure SQL, you need to create a linked service. So for each individual component of the data source, we'll need to create a data set so that Azure Data Factory will know what it is. Like for example, if it's a storage account, the file format could be anything. So in that case, you'll need to create like if it's a CSV file you want to use, a CSV data set. If it's a Parquet file, a Parquet data set. So how it boils down is linked service is the something that you'll use as a reference for the external service. Data set is how you would actually let ADF know, like this is what I want from that external service. And all this we can invoke via the activity, which all comes under the pipeline. So here we see linked service, which we actually talked about. And in this example, you can see like we are creating a linked service for Azure SQL database. And we need to give like the URL of the Azure SQL server and like the database name. And here I'm doing SQL authentication. So you'll enter the username and password. So for any other different types of data source or external service, let's say Databricks you have, you'll need to maybe give a personal access token, or GitHub you want to connect. GitHub credentials it will be asking for us here, and we'll need to give that information. So the next one is data set. And here you see, here the data set will be referring to the linked service that we have created earlier. And then in the table details, we'll pass like the schema name and table name. And here I've created as a parameterized one. So you can pass in any schema or table name you want to get data from. And this data set will be able to do it. And next thing we have is an activity. And here we have two activities. The first one is copy activity. Second one is data flow activity. So let's say you just want to move data from X to Y. Then you don't need to use a data flow. You can just directly use a copy activity where you tell like, this is the source, this is the sink. And in source, you'll need to create what we did in the previous step, a data set. And for sink also, you'll need to create a data set. A data flow, it is also following the same pattern where you'll have a source and a sink. But in the intermediate sections, you'll be able to do some transformations on top of the data. And finally, we have the pipeline, which is the grouping of the activities. And a trigger in ADF terms is what you tell a schedule. Like if you can create a trigger for it to run every hour, every day, or some event for it to be triggered to, and that is called as a trigger. An integration runtime. So all this Azure Data Factory needs some place to run. So that is the integration runtime. It's like the compute infrastructure it is leveraging to run these. And if you create a new Azure Data Factory, you will get a public integration runtime. But let's say you have data on on-prem systems, then we can create our own virtual machine and then create that as an integration runtime so that all the transformations, all the processing will be happening in that virtual machine, and we'll be able to leverage that as an integration runtime. So yeah, so I think this is where we come to the actual part of the talk. So mapping data flows, as we talked about, it's like we have a source, we have a sink. In between, I don't want the data to go as is. I want to do some operations, transformations on top of it. So how I will do it without using a code. Like I don't want to use some code like Python or any script to do it, but rather I would like to use some UI way of doing it. And that is how data factory, data flowers came up. So, yeah. So for creating any data flow, you have 5 steps. First one is like preparing the environment. Like you need to create the data sets you want. You need to create the linked service you want. Like I'm going to use Azure SQL, Azure Azure storage account. Then I'll need to create the required linked service or the storage data sets that I want. And you need to first create a data flow activity. So maybe I'll directly show as a demo. So in the authoring section, you have like different components here. So this is the data flow. So let us create like a new data flow. And here in the UI, you can actually see we can give like a name for the data flow, and we have something called as a data flow debug. So when we actually created a data flow for us to test some transformations, Azure gives us like a test cluster on which we can able to see some preview. Let's say, for example, I'll add a source and I'll say sources. And we have already created some data set. And so source CSV. This is a CSV file in a Azure storage account. So I've created some CSV files in an Azure storage account. So the file we'll be using is restaurant reviews. So yeah, that's it. Source CSV we'll select. And then in the debug settings, we'll give the details like container I want to connect, what folder name, and what is the file name. So since we have actually enabled the data flow debug, we'll be able to immediately preview what data the file actually has. It will be like a subset of the data, and that also it's configurable. Like here we can say how many number of rows we would actually want to see from that particular data. And one more thing to be aware of here is, I think this data flow debug is not cheap. Since it is using Spark clusters, it will be a little bit expensive. And even running data flows itself, it might be expensive if you're not properly configuring it, because here we don't have that much customization capabilities also. So it's what Azure gives us. So we, like, at least in my experience, for projects where the transformations might get very complex, or we will need to keep on maintaining it properly, then going for a service like a Databricks as a way to do the transformation might be much better. Like how we did it in our project is, instead of data flow doing the operations, we'll use like the source sync capabilities of Azure Data Factory. But all the intermediate transformations, we had like a Databricks notebook created, which will do all the transformations. So here, now we see like we have the data like restaurant, reviewer, review rating. It's a subset of the data it will show us. And one more thing we can do is like we can import a projection, which will automatically infer like what data type that particular column is, the column names of the data, all that it will be able to get for us. So here we see a restaurant string. We can change if we want to. String rating, and rating I'll change to integer. Time I'll for now leave it as string. Picture, and also added like a dummy column, which I thought I'll remove.
It's a virtual thing, no? Not a copy of data, correct?
So right now it's actually connecting to the file and then reading the data and getting it. It's like a subset of the data, sample data it is running.
No, no. When we connect from the source, I think that it will not be copied from the source and it will get copied into data factory, correct?
It won't. Like right now it won't.
Then how we can change the data type?
So
or what makes sense changing the data type?
So it will be like, so source is what we are right now. So when you change the data type, what you will going to write to the sink, it will change. So it will not affect the source of the data. But let's say I want to write it to another file. In that file, it may be the data type will be changed. So in the further flow of the data, all the transformations will be applied, but not in the, it won't shift left.
Okay.
So right now, I think we have done 2 steps here. Like we have prepared the environment where we have started a data flow debug. We have added a data flow activity and link service and data sets we have created. And next we are supposed to add like a source data mapping flow, which I have already done. So one more thing is we can have multiple source data as well. Like there is no restriction, like one source you need to have. You can have multiple sources. We can do some joins on them, union, all those things we can do. So before going to the transformation, we'll maybe first look at the data as to what it is, and then we will start with transformation. So the data that we have right now is like a restaurant review data set. So we have like a restaurant name, who reviewed the data, what review they gave, and a particular rating from 1 to 5. And then at what time they have actually given it, and some pictures, like does the review include pictures? In that case, like how many pictures it includes, and a sample column, a dummy column, which has no value. So the type of transformations we would like to do is like some irrelevant columns I have in the data, so I'll need to drop them. I would want to create some new features, like I want to have review length, maybe for the ML model I'm doing. I want to have like a flag has pictures where it says yes or no if the review has a picture, so that I can maybe fetch from another data source. And one more thing we'll be doing is like for all the rows which has rating as 3, we'll actually skip them. We'll either take the minimum ones or higher ones. So that transformation also we'll do now. So first we have created a source. So here we can see there are a lot of different transformations supported by data flow. So multiple inputs and outputs is like, if you want to join a different with a different data source, we want to do a union. It essentially combines multiple sources, or before going to the sink, I want to split the data, then in that case, we will use the multiple inputs or outputs option. The next one is the schema modifier. It's like similar to how in Pandas or Spark, we do a select, we can pivot the data, or we can do some aggregations, like the rating aggregation we can do for a restaurant. This is the average rating that it has gotten. That's like an aggregation operation. All these things come under the schema modifier. And one more thing we have is the row modifier. So the schema modifier does it at the column level. So if you want to do it at the row level, we need to use the row modifier. Like filter, we can do sort. Alter row is for like updating. If I want a particular row to get updated or deleted, we'll be using the alter row. One example also I'll maybe show for that. So first, what we want to do is drop the irrelevant columns. So we'll use a select transformations, and we'll select relevant columns. So then it will actually give us like, these are all the columns that are actually available for us, and what columns do we want to know, take. So dummy column, we will actually remove it. And the reviewer column, what I'll do is I'll change the name of it from reviewer to reviewer name. So here we do like two transformations, which is like dropping columns and then renaming the columns. So that first part we have done. So next thing we want to do is we want to create a few more columns. So we'll take a derived column transformation. And in the derived column, first one we want to do is review length. So for transformations, ADF gives us this expression builder where it kind of gives like a different sets of functions for us to run, like abs for getting the modular value. If it's like a time format, we can add some days, and some more things like length itself is a function. So we have like a length function. So essentially this is like Spark, similar to Spark SQL functions. So most of the Spark SQL functions which we will have, we'll be able to find them here. So I'll take length and then I'll take review. Now what we'll do is like till now we have done this transformations, and we like to see if this transformation has happened properly. So we can once again use the data preview option to try to see what has happened. Yeah. So here we see review length is a column that we transformation, we derived column we just added right now. So new column with the length of the review is getting added. Then some few columns we actually had dropped, like the dummy column, and then reviewer we have changed to reviewer name. So that has also happened, which we can see in the preview. And yeah. Next one, what we will do is a filter transformation. So the filter one, what we'll do is like we'll say, filter the ones where the rating is actually equal to 3. So we'll take rating not equal to 3. Once again, we'll do a data preview. Yeah. So yeah, it actually filters out the ones where the rating actually should be 3. So if we see in the previous step, we had like ratings with 3, but in the filter step, it actually gets removed. So similar to this, like we can, as a series of steps, keep on adding much more transformation. But where I actually see a challenge in this one is like in a code way, we can doing it. It might actually be easier for the developer to be able to understand, debug, come back to it, make some more modifications. But in this data flow, let's say like at some future junction, like the derived column has like a very drastic change, then I need to ensure like I need to individually go to each of the activity to check if that doesn't have a column which is getting used in the derived column. So these kind of complexities are actually there in data flow. Yes. So two more transformations we'll just add in the derived column. One is, I think, has pictures. In has pictures, we'll do like so what we need to do here is, I think, like if the picture is greater than not equal to 0, then we'll actually keep it as, I think, a Boolean 1. If not, we'll keep it as a Boolean false. I think I have that transformation also here. So here, if you see, I think like case, if it equals 0, we set like there are no pictures. If it's like either 1 or more value, then we'll keep it as the picture is there. This transformation will do. Check. So pictures, if you see, like it, I think I have it as a uh, string data format. So I can go to the source, and then in the projection, I can change it to integer. So once I made this change in the schema projection, we can once again do a data preview just to check if something is working right. If if actually the data type change that I'm actually doing is not the right one, the data preview will actually fail, and then it will also show me the error. So pictures, it's still showing up. So now we will go to the third one, which is derived column, and then run the see here with the error has been gone, and we'll refresh this again. So we have that has pictures updated. Yeah, if it's more than 0, it will be showing as yes. If not, it will show as no. So like this, like each business requirement we have, we can keep on adding it as like a step in this one or as a derived column, and we can go ahead. And the last one is like we create a sink. Like I've extracted the data, I've done all these intermediate transformations, and I need to write it to a destination where maybe a downstream consumer or a machine learning developer will be able to start using the data from different purposes. So for that, we'll be able to write to a sink. So for a sink, we will choose Azure SQL. Then in the settings, you can see like right now we'll only do insert, and we can also have some pre-SQL or post-SQL scripts. Like maybe you have some logging table you want to update. That scripts also we can add it here. Temporary database is like we tell data factory to use like an intermediate storage so that it can have the data there, do the transformations there. This will be helpful if the data volume becomes higher, so that like it won't try to do all like maybe in one flow, but have like an intermediate file where it will be maintaining the uh, intermediate data. And errors also we can configure if we want to log the errors to some place. And one thing in the sync is like we have this capability called as auto mapping. Like let's say we don't want to control what data comes to the system, then auto mapping, what it will do is all the data it is there, it will try to see if in the destination a column like in the same name is available, then it will, or some by pattern, it will try to match and then do it. If not, we can toggle this off and it will give us like restaurant column goes to restaurant. That kind of mapping we can have. Or if name change we want to do also, we can do it here. So this kind of gives us much more flexibility on what columns we want to have in the sync. And we will try a data preview here as well. I think we have some errors. Let me check. So for the sync, we have not given like what table it is supposed to write. So we'll open the debug settings, go to the parameters, and in the sync, we have DBO as a schema name and table name as restaurant review process demo. We'll save this. Yeah. So I'll need to allow schema drift. So when we since we have it as a parameterized one, it will need to have a schema drift. So since we set it, it will be able to dynamically, whatever parameter we'll give, it will be able to dynamically take the data type, all those things in the sync. If this is toggled off, we will need to kind of hard code, like this is the schema, it will be there. Like this column should go to a string, this column should go to an integer. Since for this example, we will toggle this one. So if this actually takes much more time, we can also control, like, as I already said, like row limit we can control. Or if we don't want to actually go to the actual data, we have an option called a sample file, like some temporary test data source file we can actually create and have it in a storage account. And from there, we can actually try to test if all the transformations happens right, and then move forward. Yeah. So this is the final data we'll be writing to sync. So what I'll do now is I'll save all this data flow. So one more thing is, like in Azure Data Factory, we don't have to manually go and save this in a Git repo. We have this option to connect our Git repo directly. We can tell it like, this is the branch that I want the source, all the pipelines configuration to be maintained in. So I've already done that. So if we see here, so the Azure Data Factory like has directly been writing all the, so we added this data flow. So it has added that here. And it will have it like in a JSON version way. And if we want to actually get this directly also, if we go to Azure Data Factory, and here in this place, we can actually find like a JSON representation of the data flow. And the transformation that we did also, it gives like a script, its own scripting language. Like we have taken this source as these columns, and then like all the transformations that we did, all those things uh, get documented here. And this is essentially what goes as a Spark code to our cluster. This gets converted to the Spark code that runs on the underneath cluster. So I'll publish. So publish is like, we can do all kind of changes in the Azure Data Factory, but only like it's kind of like moving to a higher environment. Only when you publish, other folks will be able to see those changes, or they'll be able to actually trigger the pipelines to be run. So we have created a Azure SQL database where I had earlier run an example. So today also I created like a new table called restaurant reviews processed demo. We'll see if it has any data. So right now it's like an empty one. We'll trigger the pipeline. So yeah, so one more step to do is like we have created a data flow, but as I said in Azure Data Factory earlier, everything is a pipeline is how we can invoke something. So what we would need to do is we'll need to create a new pipeline, and then here is how we can configure the activities. Like if I want to run a data flow, I can select here. If I want to run a copy data, I can do it here. Let's say you have an Azure function script that you want to run. You can just pick an Azure function activity, drag and drop to the UI, and then say like this Azure function is what I want to first invoke. Maybe that will bring the data to some place, and then we will do the transformation. Like that, it has Databricks integration and data. I think like Synapse data analytics of Azure also. Then some regular activities like failing the pipeline if you want, appending some variables, like making like a REST API call using web activity. All this activities are supported by ADF. So we will do data flow. And in the data flow, we will select the one we created now, which is data flow 1. And in here, you see we are passing the parameter. Like this is where I have my source. This is the destination. And let us save this one as well. So this is saved, we'll publish. So while this is getting published, like I've created another example. So here in this example, if we see, what we're essentially doing is like we have two sources. We have like two files, source strip data, which is a CSV file, and another file called as a driver information, which is also a CSV file. So here, like the in the previous example, we saw mostly like in a particular single source, we were making changes. But here we can also do some joins. So if you see, it allows us like full outer join, you want to do inner join, left join, or right join. And then the join condition also we'll be able to choose like vehicle ID from the left table should the right table's vehicle ID. This we can do. And then one more thing we have is called the conditional split. So the conditional split transformation essentially, uh, I have a data, but I don't want all the entirety of the data to go to the same destination. In that case, I'll use a conditional split, saying maybe ratings which are greater than 3, or like in this case, if the trip distance is greater than 12 kilometers, then I'll take it to one database. The ones which are lesser will go to another database. And then here, if you see, I've also used aggregate operation. So I've grouped by vehicle type and then done an aggregation. Like I've taken like an average one. So all these different kind of transformations, which you essentially do in a code, we will be able to do that via Azure Data Factory. Trigger this. Yeah, so this is what actually we have built right now. So we had a CSV file and a source. We created a linked service. Then we created that as a data set in the Azure Data Factory. Then we created a data flow where we did some minor transformations on the data, and we called that via a pipeline. And then same for the destination, we follow the same order, a data set, a linked service, and a table to write the data. So yeah, any questions? So I see.
So since this is expensive and you have a huge data set, you're just converting the CSV into a data set and then have a ETL pipeline. And then converting after the ETL, you again save it to a SQL database. So what if I just write a Python script using a notebook something and convert the CSV into a database and do just the SQL basic ETL and have a store procedures or triggers to do the same thing? That will again save it to a database, right?
So for this example, this like basic one. So essentially that's how it's mostly done right now. So you have a Python script, like even in our project, we use like a Databricks notebook, which will read from Azure Data Factory. So we don't use this much. So when this will be useful is when maybe the person who's developing this does not have like advanced, like he's not coding ability, like he just wants to use some UI way of doing some transformations. That is one. Next step is like where I see this also useful is like for if you want some quick turnaround, like you don't want to spend time on setting some code up, you just want to get data from X to Y. Maybe you're doing some kind of analysis, or you just want to do some minor transformation. It's just a basic file transfer. But before that file transfer, you want to do some minor modification to the data. Then going to the code might not be, that will take some setup, that you'll need to see where you will be running the code, all those things. But in that case, using this might be helpful. So in our project, how it is used is like we are doing a data migration, which we are not planning to maintain for a long time. It's just a one-time migration with where we will do, and the transformations are also not very complex. It's very simple transformation, like drop some columns, change some column names, some data type, do some things, and join from another table. So in these scenarios, specialized scenarios, this is used, but mostly the code way of doing it is what is very prevalent. but this is also getting used here and there for certain use cases. So yeah, I think talking on the same line, we'll talk about the disadvantages here. So it's not very ideal for highly custom transformations. And in that case, my suggestion will be to go to Databricks, which I've used in the past, or you have like HD Insight, I think like Synapse Analytics in Azure itself, where it will give you a way to write some Spark notebooks. There you can use some code to do it. And second one is like limited control over Spark environment. Here, the some consideration you have is like you can set the partition of how the data set will be processed, but beyond that, you won't be able to do a lot of configuration. And the cost also, since you don't know how the cluster is maintained or how the code actually gets properly executed. So you can see some up to some level, like it shows like in what stages the data flow is running. But for larger volumes, it gets harder to track how where the cost actually spikes. And the data flow debug also, if let's say we have like a lot of developers on your team and everyone is like creating their data flow debug for some small clusters, that also can become quite expensive without like you anticipating it. And since if it's like UI based, as the transformations keep on getting added, at some point it gets harder to track like where what changed, or you might miss some transformation or miss some important column that you wanted. And since it relies on Spark clusters, the pipeline itself, which we triggered now, it will take some time, not for the actual transformation, but for the cluster itself to start up. This one is prevalent in Databricks as well. But as Spark cluster we're using, for the Spark cluster start itself, it takes some time, which for certain use cases might not be ideal. And in the same line, it's not designed for real-time processing. It's mostly for a batch way of doing things. Real time, we can do it to some extent. I have not tried it, but it's mostly built in keeping the batch way of processing in mind. So I think the run succeeded. So once inside the run, once you have run, you can actually have this option to see like what has gotten written. So here it says like 8,644 rows has been written. So from the source, it had like 10,300 rows. Then it did some transformations, and we had like that filter step where all the reviews with rating 3 got removed, and like around some 8,000 only got filtered, and it got to the sync. If we run this, so now the sync has the destination, like hash pictures has been added, review length has been added, and yeah. So I think that covers the aspect of the talk. Any questions or anything here?
Data.
So as you said, like for complex transformation, we'll be going for Databricks, right? So is it like, so once I'm done with writing to the sync, it will write it, it will read from the sync, then it will do the transformation, that it will write to somewhere, right? Or how the flow will be? I just want to.
So for that, how I've done in the past is like here in this pipeline we have. So there's one more thing called copy activity. So let's say we use this copy activity, and in the sync we have like a storage account or something. We can say like this is where I want you to write. Maybe Parquet file or anything we can write it. Then we can select Databricks. So Databricks, for this also a linked service you'll need to create, like this Databricks environment I want to connect to, all those we will need to create. And then here we'll be passing like the notebook path, like this notebook inside Databricks I need to run some parameters, and then we will be able to trigger it, and we can connect it. Like once the data has been copied, then in the next sequence run the Databricks notebook, maybe another notebook if you want to run, we can keep on adding it and then take it forward.
That copy will copy from where?
So it could be a source. So copy activity is not compulsory. If you don't want that, we can do all of that in Databricks. But in that case, then ADF itself might be a question, because Databricks workflows are available where you can sequence notebooks there. So if you want to leverage Databricks, Azure Data Factory, we can use copy activity. If not, Databricks also can read from the source. Like the code you need to write there, but in copy activity, it will be like in UI itself, can just set what source or what sync you want. You don't need to write the code. That part will be cut off.
Fine.
So ADF uses GitHub, Git for version control, I believe. So for each publish, it will write to the GitHub repo, I believe. Correct me if I'm wrong.
It's the save one actually. So there are two steps. One is save. So save, it will like return like a commit and then say like these are the changes.
Okay.
And then it will get added to the GitHub repo. So it will say like saving in the Git repository.
Right. So as you said, the pipeline will grow faster for complex logics, I believe. And if there is any bug in the newer logic, will I be able to get back to the older commit or undo the changes?
I think direct rollback might not be available, but one thing is like you can just, if you have like a older version of the one, you can just come and delete it and then copy paste the new one and it will get loaded.
Okay.
I don't think there's a direct way of doing it. Maybe we take a older commit, find that files and then move it. Or like we do in Git way. I think here we won't be able to do. We do it in Git, like we apply the old commit on top of the new one. And then here we tell it to pull the latest changes from the.
Got it.
So Git also is not mandatory. So it has its another mode called as like live mode where it won't save anything to Git. Azure Data Factory will internally it will maintain, but it will only have the latest version. So you won't have a way to go back or make any new changes. And all changes won't be tracked. So if multiple people are working, there's a possibility there might be some overlap if both are working on the same pipeline. So that's why that is also available. So publish updates the live mode. So when I say publish, the live mode one will get updated. So that happens.
Understood. So save is common for all the users. If I save, it will reflect for everyone. Am I right?
So they'll need to either refresh it or pull the latest changes. I think that might be needed to do. I don't know how real time it gets reflected. But
I was about to ask on the lines of conflicts. If multiple people are working, if they just save, will there be any conflict?
It has happened actually for me. Like I think we had like dev staging prod environment, and every time we move from that ADF dev branch to that one, like we'll need to spend some time to see why. Because initially it was easier, but once we had like some 20, 30 pipelines, I think each person was making some change. So it's like developer practice, like discipline of ensuring that is what should work.
Good. Thank you.
Okay, thanks, Anthony, for that. That brings the day for a wrap, folks. Thank you so much for joining. Before that, a small announcement. This is the WhatsApp community. All information about the upcoming talks and all information that we folks want to convey to you will be put up here. So please join the WhatsApp community. And we will be putting up a form to collect your feedback. What you folks think is important for us, and based on that, we are improving the program month on month. So please give your valuable feedback, and dinner is served. So a special shout out to my friend here who actually came with his father not to miss this month's event. So thank you so much for joining. Please have dinner. We will see you next month. Every month's last Thursday is Geek Night day. Bring a friend along. See you. Thanks.